Good morning, everybody. Thank you for joining us. I know it's the first, or not this first session of the day, but it's still fairly early. And this is one really large room, and I can see there are people sitting way in the back. Why don't you move forward a little bit, and we can do this a little bit more interactively, if you guys don't mind. It also means I don't have to stare into the lights to try and see where you are.
And we are the session standing between you and lunch, so we'll try and keep this interesting.
Although I've just finished breakfast. Okay, my name is Sean O'Mara. I'm Field CTO with Mirantis. I've been working with the Reliance team now for a little over a year. And it's been some really, really interesting year. We'll share with you this morning a couple of stats and details about what they've done. Go ahead.
I'm Mayank Kapoor, Head of Engineering for Cloud.
At Reliance.
At Reliance.
Hi, I am Mehul Jani. I am a DevOps manager. Basically, I belong to the DevOps team, which manages all the clouds, which are currently running at Reliance. And we are responsible for even deployment of the additional clouds. I have been with Reliance for the past 1.5 years. So that's all.
Cool. So over the last 4 years working with Reliance, we've learned a number of really interesting lessons about building out OpenStack at scale. We've been doing this with various versions of OpenStack. We started with Juno, with our Mirantis fuel deployments. Over the last year, we've been implementing MCP. Is this thing working? So just a quick 2 minutes on Mirantis. I'm not going to go into a lot of time and detail here. Mirantis is a whole policy. We launched our Mirantis Cloud Platform product just over a year ago now. Our entire focus has been about managed, open cloud delivery. Everything Mirantis does is open. Our entire product set is available for anybody to download and utilize. Yes, there are complexities that go with that. And the Mirantis mission is to be the world's most effective vehicle for converting open source innovation into customer value. What that means to us is we use a huge number of different open source platforms. We integrate those to deliver primarily OpenStack up till now. And going forward, we'll be delivering we have the ability to deliver a number of other platforms and cloud platforms that may come out in the future. But we have spent the last 4 and a bit years focusing on delivering OpenStack and managing and operating OpenStack, which is a huge part of what we're going to talk about today. So MCP, what is it? MCP is made up of 3 primary components, or 3 areas. Drivetrain, which is the lifecycle management. It's the heart of our product. We do everything around Drivetrain. Everything we deliver is through Drivetrain. All the operational components and lifecycle management is done through Drivetrain. Then we have Stacklight. Stacklight is visibility for your cloud and applications. The idea is if you have visibility of what's going on within your cloud infrastructure, what's going on within your applications, you're better able to operate and manage those environments. And then finally, the open cloud software platforms. We're all here, we're at an OpenStack conference, we're talking about OpenStack, we deliver OpenStack. Alongside OpenStack, we can deliver Kubernetes to a multi-cloud delivery, so both public and private cloud, as well as Open Contrail, and Calico as network SDN underlays, alongside standard Neutron OVS. As our primary storage delivery, we're delivering Ceph today, but we can integrate to any storage platform that OpenStack will support or has drivers for OpenStack. Just a quick overview. I know this is not a very technical slide, but each of those blocks on this diagram are filled in by an open source platform. So for Drivetrain, for version control, we currently use Gerrit and Git. For code reviews, the other way around. For CI/CD, we're using and integrating Jenkins. Part of our model-driven architecture is we're able to create the Jenkins pipelines and insert them into the product for you and deliver those pre-configured. So for upgrades, updates, we deliver you a pipeline, you run the pipeline, it does the update. We have an artifact store. Any delivery today is made up of a combination of different types of artifacts. We try and deliver as much as code as possible, but to reduce the impact for upgrades, we also deliver immutable objects through the form of packages or containers as necessary. The heart of Drivetrain is the node classification model, or the reclass model. This is a model-driven delivery mechanism to define your infrastructure and your architecture to deploy it in your environment, both for OpenStack itself, which is a hugely complex application in its own right, but anything you would like to run on top of your cloud platform, we can deliver through the model-driven architecture. And it handles deployment. On the visibility side, we're combining a number of open source platforms like Prometheus with a Grafana for visibility, and then the DevOps portal. The DevOps portal provides you a window into your cloud environment. It provides you a window into Drivetrain itself, so what's happening with your deployments and your management. It provides you a cloud health information. What is your capacity utilization today? What is predicted? What is my application impact on my environment, etc. We also have built in a cloud intelligence portal. It is a Google-like search box that you can use regex-type searches to deliver and provide information on what is happening within your cloud today and last week. We have included the Netflix Janitor Monkey, Security Monkey, so the whole Chaos Monkey set, so that you're able to utilize those within your cloud and do your testing to determine your application health. We've given you runbooks. So for those of you who are not necessarily wanting to give full access to the underlying cloud infrastructure, you can create runbooks for your operations teams to utilize. And finally, I've mentioned the LMA and a notification solution. So I've covered Drivetrain. What I would like to see, we've just recently developed and delivered our containers as a service offering. We're able to deploy Kubernetes clusters, provide a catalog of Kubernetes clusters across a multi-cloud environment. If you'd like to see more of that, please come down to the booth, and Jakub is there. He can demonstrate that to you. It's a very unique way of delivering Kubernetes across both private cloud, bare metal, and public cloud solutions, and is agnostic to the environment that it's running on. So who's Reliance?
So the topic of this talk today is cloud at scale. Why do we think we can talk intelligently about scale? I want to give you a quick background about who we are and what is Reliance Jio, and why we think we can speak about scale. So Reliance Jio was launched about a year ago, September 2016. We are the fastest growing technology company in the world. And let me give you some numbers to put this in perspective. We launched an all IP network, which is a default LTE network. So typically telecom networks, they started with 2G. Typically, for example, AT&T is 3G in most parts of the US. And where they have 4G available, they latch on to 4G. Same thing in India. You have 2G networks predominantly. They started offering 3G services. And then in small pockets, they offered 4G services. Reliance launched last year with a primarily total all IP network, all LTE network. So by default, you latch on to LTE. That's a big deal in India, right? LTE gives you access to very high broadband speeds across all parts of India. Before Reliance launched, probably like 80% of India had network connectivity. The villages and the remotest parts of India didn't. Now with Reliance, our coverage is more than all the other operators combined in India. That's a big deal. When we launched in September 2016, in 170 days, we added 100 million users. That's faster than WhatsApp. That's faster than Facebook. So we don't make that claim, the fastest growing technology company, just for kicks.
It's 100 million new smartphones in India.
Correct. Our users make 2 billion minutes of video and audio calls daily. Audio calls are free on our network. They will always remain free. SMSs are free. They will always remain free. Data is chargeable. And that's how Jio makes money. We give access to very high-speed data at very low cost. The cost of data in Jio is the lowest in the world. We offer 1 gigabyte of data at 100 rupees, Indian rupees. That's $1.50. That's lower than any other network in the world. Our plans currently, typical plans offer 1 gigabyte of data every day, and the cost of that plan over a month is roughly $5, $5 US. Our network currently carries over 55 million hours of videos on its network. So let's see what scale are we running at. So we launched in September 2016. Quickly, in 1 year, we've grown to 140 million smartphone users. And these are users that are using TV on their phones, listening to music on their phones, watching movies on their phones, backing up all the data to the cloud. That's the typical use cases for our users. The total monthly data consumption is up 9x in India, right? To 1.3 billion gigabytes a month. Before Jio, it was 0.2 billion GB a month. Quickly after Jio, I say that India was a data-starved country, a data-poor country before Jio launched. As soon as Jio launched, because people were craving to use data, the uptake was phenomenal, very fast. And quickly with Jio, India has actually leapfrogged most other countries in the world. We were 155th in the world before Jio launched in terms of mobile data usage. Now we're the first. So that's a big deal. That's why we think when Jio is can run things at scale. We're growing very quickly. And along with our network, we also offer a full suite of cloud services that we use OpenStack to run. And these services are free to Jio subscribers. We have apps like Jio TV, about 75 million downloads on the Play Store. Monthly actives are about 35 million monthly active users. Jio TV is free to use, so you can watch TV on your phone. Jio has also led a cultural shift in India on how people consume media. Before Jio launched, people used to watch TV on their TVs. In villages in India, they used to have maybe a shared TV where all the people congregated and watched one show. All of them watched the same show. Now on their phones, each person is watching TV on their phones, which is a huge mindset shift, a cultural shift. And they're able to consume, they're able to watch whatever they want to watch on their own phones. So that's a big deal. Jio Cinema, free movies on your phone. Jio Music, free music on your phone. Jio Money is our payments bank business. It helps you transfer digital money from one person to the other, pay at shops. Jio Chat is our chat client. Jio Cloud helps you back up your phone. If you lose it, you can restore your data. All these services are running on our OpenStack cloud. So let's look at the scale of our OpenStack cloud and our journey so far. And ask questions if you have any. We started in 2014. At that time, I think the first cloud was about 150 odd nodes, 190 nodes, I think. We started rapidly scaling up that cloud. And currently, we are already, this is a number I got to know at this conference. The 100K core number is apparently a pretty big deal. I didn't know that. We're almost at 100K cores already. When Jio is up and running at scale, we'll be 14 data centers across India, 30, 40,000 bare metal servers. We might actually hit the 1 million core number, but I'm not sure yet. And that is the phase we're currently in. Currently, we're across 4 data centers. We have multi-data center cloud, 4,000 odd bare metals. So this is the scale of our OpenStack cloud running. And what have we improved or what have we learned during this time? It has taken a while because to get a production cloud running at this scale takes time and experience. And one of the key things that we've improved is the rapid deployment of cloud. If you look at the Jio business, we're going to scale out to a massive number of data centers, servers coming in daily. We can't afford to keep those servers lying around not being part of the cloud. So a lot of focus together with Mirantis has been to reduce the time it takes to get bare metals into the cloud, sort of build a factory of bare metals coming into the data center, rapidly getting added to the cloud. If you look at our journey, initially, when we started, it took us 55 days to set up a 100-node cloud. That started reducing with process improvements. Now, with our infrastructure as code cloud deployments, with the inventory model, the reclass model Sean talked about, we can add new bare metals as soon as they're racked and stacked And of course, network is configured for those bare metals. To our code in the reclass model with a pull request. As soon as it's added in the reclass model, that node can get added to the cloud in a matter of 2 hours automatically. We just run a Jenkins pipeline, the Drivetrain pipeline, and the node gets added. That's a compute node. To set up a 100-node cloud now, we can set up that 100-node cloud in less than 24 hours after racking and stacking. That's been a big focus for us, because the amount of energy the amount of time and effort we would have wasted if we had kept on doing 55-day cloud deployments is massive, because to scale out to 14 data centers, 40,000, 30,000, 40,000 servers, we would have wasted so much effort if we had not automated these things. So now, within 24 hours, we can automate, and we can walk you through how that happens. Jio's culture also is built on microservices. We have a microservices culture and an org that reflects microservices. We want our teams to be independently scalable, their services to be offered independently, independent deployments. And as soon as they start having requests for more resources for their services, because we're adding an extra 10, 20 million users quickly, we want those resources to be added to the cloud fairly quickly. That's been one of our focuses in our journey so far. Monitoring is a huge component for us. We want to be able to predict failures before they happen, and that's still currently in process. We haven't learned everything that we want to learn in monitoring. So that's another focus area for us currently. So I can't stress automated deployments enough. If you can add your inventory bare metals going into cloud in code, and then configure that bare metal, configure your cloud through an automated pipeline, that is going to help you run cloud at scale. And it'll make the process much more repeatable for you. Not just cloud, I think for all your software services that you guys build, microservices that you're running, make sure everything's automated from the start itself. So let's talk about our services stack that our cloud runs. We have multiple data centers, 4 currently, two in Mumbai in India, 1 in Jamnagar, 1 in Nagpur. On top of it, we offer multiple service to the microservices teams within Jio. We offer a multi-data center OpenStack cloud. We still haven't figured out a multi-DC workload orchestration, which is a huge focus area for us going forward. But we can offer clouds with DR sites, recovery sites in a different data center if one data center is not available. So that's a nice thing. We offer bare metals as a service to our teams. Some teams choose to run Terraform environments. Some teams want containers. Some teams use the Murano application catalog to set up their services. Our goal as the cloud team is to provide these services to the different teams in Jio and let them use whatever they're most comfortable with. And what the Jio teams have done on top of our cloud is run microservices, run typical state-of-the-art DevOps tools, Prometheus for monitoring, Grafana for the dashboards, build CI/CD pipelines for those microservices. So based on whatever I've seen in this conference, I think we're doing similar stuff. We use Linkerd and Console for our service discovery, connecting all these microservices together, and they all run on our OpenStack clouds. We have a huge focus on big data that Mehul is going to talk about, but for a telecom network, that's a huge area of focus for us. So Mehul, why don't you talk us through our big data journey?
Sure. Do you want to show the deployment? I've sent you the video.
OK, sure.
Yeah, we can actually. OK, so I think so Mayank and thanks, Sean. They have given us some kind of a perspective of how do we use Mirantis MCP platform to go ahead and expand our cloud. And Mayank has given us a perspective on what scaled really means for us. We are looking at a scenario where customers have come to us and said, okay, you have added a node to the cloud, you have created a cloud for us, but how do I use it? And one potential way to do around is we actually go ahead and ask customers to spawn the VMs, spawn networks, create security groups. It's a long process. And the easier thing for us to do was to come up with Murano catalogues, which do the exact same thing, but a repeatable kind of provisioning. And one particular area which we needed lots of clusters to be created was big data. The kind of options that we wanted was users wanted to go ahead and have more disks attached to the VM. They wanted specific groups. They, for that matter, did not really care what solution did we come up with, but they wanted their clusters to be up and running in a matter of time, right? So what we landed up doing was putting up a few Murano catalogs. Maybe I can show you a demo later. But the case is that what we tried to do was to use the base services that OpenStack provided and created a scalable solution. So even if this particular solution has, say, 3 big data nodes, or say 5 big data nodes to best of our practice, it can be scalable. It can be made into a production cloud, a production big data cluster almost immediately. And that is possible because of the way we have actually gone ahead and engineered the Murano cluster. This Murano cluster actually is nothing but, Murano catalog is nothing but a process which is followed for setting up the VMs, setting up security groups, deploying applications through Ambari, which is the Hortonworks distribution. And a few of these are basically Kafka, Flume, Spark, and it actually allows the end user to go ahead and play along with it. It can be a case where data can be ingested using Kafka and Flume and test out a few business requirements, or I can go ahead and basically give this complete cluster to a user where he can play along with it for a fairly good amount of time before saying that, okay, I want to destroy it and I want to create a new one. So it was that repeatability that we were able to achieve. We are actually working towards a lot of other optimizations. And one of the optimizations that we came across was to go ahead and use the block device driver and to use the disks which are there on the compute nodes itself. We have started our POCs on that. We have some of our customers actually testing it out for us. And I think so that those are some of the things. Secondly, we are moving towards a way, in the exact same way, we can use Spark workloads of enabling GPUs on our compute nodes. So what we have landed up doing is creating exactly the way Drivetrain has been to us. We have created solutions that way where we can go ahead and give it to our customers so that they can scale to the optimum level. Is there a way we can actually go over that?
Yes, so we want to show you a video, maybe a sort of a live demo of what we've done with our big data deployments. Again, the focus is if you want to run things at scale, try and automate as much as possible. So
So whilst they're getting there, just add some color. So what Mehul was talking about is the work that we've done with Drivetrain, the work that they've done through the Miranda catalogs, is they're able to now integrate what they're doing at an infrastructure layer with Drivetrain and the change of providing disk, for example, on compute nodes. They can call for that through the Miranda catalogs to the Drivetrain APIs and prepare the hardware, the underlying hardware that way. What that means is we can start to better utilize the infrastructure that they have in their environment. They're racking and stacking servers at an incredible rate at the moment. And those applications change around, they grow, they are doing a lot of dynamic work with the way that they're growing. And some of those numbers are pretty staggering. So it's been a really interesting journey, and we've learned a lot through this process as well. Are there any questions whilst we're waiting for that video to come up? Primarily Ceph, yes.
What about these videos that we talked about?
Well, that video is currently on bare metal. It's dedicated storage, it's localized storage on those nodes. Yeah, the video streaming systems are unique, and a lot of that has actually been developed by Reliance themselves, by the Jio team themselves.
So this is something that I'd like to show you. We have actually gone ahead and created a video, which is how our customers or end users goes ahead and creates uses the Murano catalog and to create Ambari cluster. So this is the application environments. We go ahead and create a new environment. And we have two Murano catalogs. One is the Ambari server, and the second is Ambari cluster. Ambari server is responsible for deploying the server component for server component. Here, it goes ahead and takes some basic information from the customer. So I could go ahead and have one tenant, and within that tenant, I can go ahead and have multiple clusters. I can have one dev cluster, one prod cluster. Maybe I want to destroy the dev cluster later. It allows me that kind of flexibility. So it's asking for basic information, and these are all the details that we take to go ahead and create the cluster. So just finished the application deployment. If you check the instances here, it will show that it has started up a server with demo.com. So this is an Ambari server. And the way we have actually structured the whole thing is that all the security groups which are responsible for the Ambari cluster are automatically added to when the Murano catalog runs. So all the responsible communications 840, 440, 8441 are added. Next, let me move ahead, yeah. So next we create a cluster environment. Basically, now we have the Ambari cluster. Now we have the Ambari server, and we will use a different Murano catalog, that is the Ambari cluster, and create multiple nodes. So the Ambari cluster is written in such a way that, say if I ask the cluster to create 6 nodes, 60 nodes, actually, we have tried up to 20 nodes together at a time, and it has worked successfully. So it requires some information on how the clusters are communicating, or which clusters are communicating with which Ambari servers. So we have another catalog, actually. So say if we have created the initial cluster with 5 nodes, and we want to add, the customer wants to add another 3 nodes or another 5 nodes. So there is a Murano catalog that we have, which are used by our customers to extend the cluster. In the sense, they can add 1 or 2 nodes as per their requirement. So this is the point where it allows us to go ahead and start the server. We will have to take this.
So at this point, I think what Mehul has shown you is you can automate a lot of things in your companies, in your stacks. Key thing is the tools are available. We just have to get around to doing it. Any questions? There's a second video too. But before that, do you have any questions on running things cloud on the content of this presentation, your experiences running cloud, trying to do things at scale? Let's open it up to questions, and let's see if we can answer those.
Yes?
What is the size of your operations team that manages all this data?
Right. So we have about 63 odd people in our operations team. We are planning to grow this team with more engineers also. So what we've started doing is we actually started customizing OpenStack to suit our needs. Till now, we've been running vanilla OpenStack, default OpenStack. For our needs, we want to customize Horizon. We want to customize a few deployments, maybe automate a few things. And of course, we will open source these things. So we've started to grow the team with more engineering. And the 63 people predominantly are cloud operators, L1 support, L2 support, that kind of people. So that's the size of our team till now. There's also a significant, which I'm not mentioning, data center team. So our team manages and runs the cloud. Racking, stacking, running the data centers, power, electricity is done by a different team. That is also a decent-sized team in Jio. So that is not included in the 63. Miranda, you want to talk about Miranda?
Yeah, let's talk a little about the structure of that 63.
OK. So we have predominantly, Mehul, you have to help me here, predominantly DevOps people in that team. How many would you say are DevOps?
So we are actually divided at multiple levels. We have L3s and L2s and the L1 supports. We have around 5 people who are L3s. We have rest of the team is actually divided across L2s and L1s.
Got it.
What we must also know is that that team is managing the entire environment. So any software operation that happens in the environment, including at the network, from the networking level all the way up the stack, is managed by that team. They own the environment and are responsible for the environment for everything but the hardware itself.
Correct.
And that's been a critical point.
And to do that, so we are to manage this scale of operations and cloud, unless we have all these things automated, we will basically burn out trying to manage all the issues. At our team size, even though we're saying we're going to grow this team a little more, you have to try and automate these things if you want to run them at any decent uptime, especially because Jio is a production network. We have 140 million production users on our clouds already. So key focus has been on automation over the last couple of years for us, which Mirantis has helped us significantly. You might want to mention your team, the Mirantis team that helps us, just to give you a size
just
number.
Just to give you an insight on the Mirantis team, we're primarily focused on supporting, obviously, our product set, but also working with the Reliance team on architecture and automation. We've set up a couple of principles around that. Everything is automate first. Even if it takes longer, automate it first. That has been a big driver over the last 8 months to a year. That's why we've been able to achieve those numbers that we put up on the board earlier. Without having done that, taken that automate first mentality, we could never have achieved that because you'd always be going back to fiddles in the background. So that's been a primary thing. Centralized configuration management. The only place anything gets changed in the environment is through the config management tools. If something gets changed outside the config management tools, somebody's in trouble. It's essentially what it boils down to. And that is handled through regular operational reviews. Right now, we're able to tell pretty quickly if the states are out, so we can do state comparison within the environment. And the team can, any time that there's a problem, the first thing they check is has somebody changed something that's not through the config management.
Correct. In fact, we actually have, so let's also talk about the process that we use to push changes into production. We are actually a typical software shop, which most DevOps teams are not. Any change that is going in, first of all, has to have code written for that change, which is very weird, right? In DevOps teams, like, hey, you go in the server, change something. Instead of that, we start with the code. We send a pull request to our code repository, the reclass model, the salt formulas that we have written. And then we set up a on-the-fly dev environment where the engineer, the DevOps engineer, or the software engineer making those changes actually deploys his dev code, sees if it's working, tests it, gets it up and ready, and then releases that environment to QA. So we have a few QA people in the team also. You release that dev environment, on-the-fly dev environment. The reason we call it on-the-fly is we actually create that dev environment running on our cloud on the fly. We don't have a physical dev environment that we do development on. So we virtualize the entire stack. It's possible for us to do because we've automated the entire deployment through code. So we use the OpenStack project to deploy a dev cloud, which mirrors our stack, deploy the changes also, because those changes are also in code, in our dev repository, the developer's repository. The developer tests it, finds it's working, releases it to QA. QA does their own testing. We also run a suite of Tempest automated test, Rally smoke test, performance testing. Not yet. So during development phase, we don't run performance testing. QA says, yeah, the feature roughly works. Why don't you go ahead and merge it into our master branch, and let's deploy it on a staging environment. That's the first physical environment we have. So that the change hits. So we deploy it on a staging environment. We run some performance tests on that environment. We regression certify that change, and that change gets deployed into production all through Drivetrain, which is basically an automated Jenkins pipeline, and that's how it goes into production. So any change any issue that is caused, the first question is, okay, first of all, this change was tested and it was certified to be working. What has caused this issue? Was it a manual change that someone made, which is not supposed to happen? So we've slowly and steadily reduced the amount of manual changes that are going in. Now, very few, I don't think, probably over the last 6 months, there probably has been maybe one manual change that has gone in that later on was sent into code also.
Just to add on to that point, so this is nothing, all these changes also have system level changes. So say if we are making changes to certain kernel parameters or anything, we try to make sure that they are, because kernel parameters and all those are basically performance enhancements. So if we see that a particular performance enhancement is going to help other environments also, it is better to be in code rather than outside the code. So we have tried to maintain that kind of changes in reclass model itself, which gets pulled over to other environments as well. So it's not only OpenStack configuration, but also system level changes that we are tracking in our code repositories.
So one of the things I'd like to just highlight, his background's a developer.
Yeah.
Will's background is a systems engineer. He is an infrastructure guy. We've had to go through this culture change within the Jio team. When we first got there, primarily everybody we're infrastructure guys, came from infrastructure backgrounds, some dev experience. They've gone through this culture change where the old systems guys have learned to be devs, and the devs have all learned to be systems guys. And that's been the big change that you have to go through. You have to start to merge the mentalities and merge the way of thinking. You've got to take guys who are used to, as you said, dropping into the server and just fixing the problem in place. And you've got to turn them into sustainability engineers and make them think about, hang on, how do I repeat this? How do I make this code? And we're getting closer to this dream of infrastructure as a code. There's still work to do, but we're getting pretty close.
The impact on Jio is massive. We have multiple clouds running. For us as a small team to run so many different clouds with different configurations was going to be a nightmare. The advantage of having everything in code is, hey, we've just finished this feature. We've deployed it on one cloud, just trigger this, point it to the older clouds, and then, hey, poof, you have that new feature on the older clouds too. So that's a huge deal for us, right? No extra effort is needed. You just do it once, and then you deploy it anywhere. So that's a huge deal.
So we're talking about 6 production clouds right now.
Correct.
Of significant size. Every single one of those has a mirrored QA cloud, which is not as big. It just has smaller from a compute node perspective, and the control planes tend to be slightly scaled down. But they're treated as their production clouds.
The staging environments, right?
They're
You have
staging
to mirror production. So maybe 12, 13 clouds running
13 clouds running
in production. That's very hard to run if there were different configurations.
Yeah. We're actually looking at the numbers earlier.
Sorry, so a long answer, maybe a little more insight to that question. Go ahead.
2 questions. Initially, you mentioned that you start the project on Juno. So what version are you currently running? That's question number 1.
Oh, okay.
And question number 2 is, you mentioned a lot of apps that are currently running on the cloud. When I look at them, many of them are all business applications. So my question is, do you also have any network applications running on the cloud?
When you say network, you're talking about NFV? Correct. Okay. There was a slide in there which I might have skipped. So the questions, let's answer the first question. Which version are we running right now? We're running OpenStack Okata. And our philosophy is to try and as closely track OpenStack master as possible. Upgrades for us shouldn't be 1-year projects, right? Which are typically the case in enterprises. For us, we want to, so what we do is, again, we're basically in the software mindset. Software development has a process called rebasing. If you've ever used Git before, all you need to do is to get the latest upstream is rebase your code. So we have our own repository. That upstream is, let's say, OpenStack master. Something changes, it flows through Mirantis repositories, and all we need to do is do a Git rebase. So we follow this process every couple of weeks, every 2 to 3 weeks. We're always running master. So that's a huge deal, right? So instead of a year-long upgrade cycle, every 3 weeks, we are the latest OpenStack, which is a very big deal. In fact, for people who have run OpenStack before enterprises, they would know why this is such a big deal. That's the first question. Second question is, are we running network workloads? Yes. So there's a huge trend in telecom to virtualize network workloads. This term is NFV, Network Functions Virtualization. It's a little slow process, though. So I'll give you one more insight. Network vendors, Cisco, Juniper, all that, traditionally have given telecom companies black boxes in hardware to do those functions. And until the network vendors virtualize those functions, you can't run them on cloud. Slowly, at really high levels, for example, in Reliance Jio, at our CEO level, Mr. Manoj Modi, Mr. Mukesh Ambani level, they're talking with the Cisco CEO, the Juniper CEO on virtualizing the network functions so that we can run these network workloads closer to our users. That's called edge computing and real-time network functions. The reason it's important is because of latency. Traditionally, hardware, if you installed in one data center, you had to run that application from that data center. Maybe your users are the other side of the world, right? If once you virtualize those network functions, you can move it to any cloud closer to that user so that the latency reduces. That's a huge area of focus for us. Even now, and going forward, it's going to be like 5x the amount of workloads that are coming on our cloud. So the answer is yes. It's a little bit of a process because you have to virtualize those network functions, and the network vendors have to virtualize those functions.
Anything else?
Gentlemen. So the SDN part? Yes. So the question is, how did we do the networking solution? We use OpenContrail. Sean, you want to highlight? So we use the Mirantis cloud platform, and one of the SDN solutions in there is OpenContrail.
Yeah, we currently implement OpenContrail as our baseline. Each of the data centers right now, each of the clouds is a self-contained entity, and it breaks out through Juniper MXs as necessary. Do you have any specific questions around that?
No, we're just working as well on an SDN solution that is also supposed to support these scales.
So, I mean, what else exists? We've worked closely with Juniper themselves in the past, so we have a number of implementations running Juniper Enterprise Contrail. OVS, the Neutron OVS deployment, a lot of work has been done in that space to stabilize it and to deal with a lot of the previous data plane issues that used to exist. So a lot of those issues have now been cleared up. That's a community. The community started a lot of work on that space. From a Mirantis OpenStack perspective, Mirantis Cloud Platform perspective, we were able to integrate to any SDN solution that OpenStack can support. For Reliance, we've done some work where we've looked at federating the various open contrail deployments to make workload migration between data centers simpler. In the background, we're working, in fact, I think I see Madhu there. Madhu is working very closely with the Reliance team, looking at the NFV virtualization and how they're going to do their SD-WAN and their bigger integration to those clouds. And then you mentioned the edge computing work that we're doing there as well.
I know that OVS do have all the control plane of the data plane in reaching large scale. I'm wondering how open control solves.
So Open Contrail in its own right is able to scale far larger because it's an entirely different way of deploying the control plane. So OVS, a number of the challenges with OVS was the way that the agents communicated back to the control plane. So a lot of that has been worked on. I don't know the exact state of it. We have got colleagues who can talk to you into that detail. From an Open Contrail perspective, you can, once you've deployed Contrail, once you've set up the networks, you can actually turn the control plane off. You can't make any changes, but it'll continue to run. And that's the primary difference between OVS. The vRouters will run quite happily on their own for an extended period of time without being able to communicate. Of course, you lose telemetry, but at the risk of keeping your data plane up, that's something you can deal with.
I'm guessing this is open flow based and the solution is whoever's open flow.
No. Contrail isn't OpenFlow based. BGP and EVPN. Madhu can answer those questions better than I can at the moment. Anything else?
I think so. We have run over
Madhu?
the
Yeah,
time.
I think.
Just one quick question. You talked about config management and automation at the infrastructure level. Does it extend to higher up the stack, like the big data systems, software and applications, the Jio, TV applications, things like that?
I keep coming back to the statement. So the question is, the automation that we've done, is it only cloud specific or can it extend higher up the stack? Again, we are a software shop, right? All we're doing is we're using the best practices in software engineering. We're using Jenkins as a CI system, infrastructure as code, automated deployments. You can use all these things in open source that they already exist higher up the stack. To build your microservices, to run your microservices, you can actually run microservice on Drivetrain. Sean might want to highlight that. Using software development best practices, doing big data deployments, using Drivetrain, all that is possible. But key message is, look, these are just best practices in software engineering. Yeah. If you use those best practices, no matter which tools you use, you just need to understand why you need to use them and then use them effectively. Multiple tools available to do that exact thing.
Except that what we've done with Drivetrain is we're using a set of open source tools. Everybody is familiar with Jenkins, Gerrit, and Git. We're utilizing those tools to be able to deploy complex applications. We see OpenStack as just another complex application. So that same Drivetrain deployment, the same set of infrastructure, the same models can be utilized to deploy applications on top of the cloud infrastructure and is being used in some environments. We're doing some of that work right now for the NFV work at Reliance.
Right.
So we're actually going to deploy NFV workloads for testing purposes and preparation utilizing the Drivetrain, the same Drivetrain capabilities. Okay.
Great.
I think we're over our time anyway.
Thank you for the discussion. Thanks for coming.
Thanks, guys.
Thanks.
Thank you.